So we've used the periodic table to figure out how many protons, electrons, neutrons are. We now know what the atomic mass means, what the atomic number means, and so forth. There's one set of numbers on each periodic table entry, though, that we haven't talked about yet. They're these numbers on the bottom. They're smaller. It's a series of numbers with dashes next to them. Does anybody notice anything about the numbers or the pattern of numbers or what they add up to? Taylor?
They both start with 2.
Yeah, these all start with 2. Grady?
The numbers on the bottom add to the atomic mass. Atomic.
Close. Yeah, the numbers on the bottom add up to the atomic number.
Yeah, atomic.
Okay? This is what's called the electron configuration. So we know in aluminum, how many protons are there? 13. And there must be 13 electrons. And if we add up those numbers, they add up to 13. Okay? So the electrons that surround the nucleus, they're not just randomly spread around. They have a certain pattern where they are found. There are what we call different orbitals, sort of layers around the nucleus where you can find these electrons. And there are several orbitals, and as electrons fill in those orbitals, orbitals get full, and then electrons go to the next level up. And once that's full, electrons go to the next level up. So that's what those numbers are telling you. And so what we're going to do is we're going to learn 2 ways of drawing a model of an atom to show this. Okay? First is called the orbital model, and it's really fairly simple. What you do is you start by drawing a circle in the middle that represents the nucleus of the atom. And we write in there, okay, the number of protons and neutrons, because they're found in the nucleus. So how many protons did we say for aluminum? 13. And how many neutrons? 14. Okay, so that's the nucleus of our atom. Then we draw the orbits where you would find electrons in concentric circles around the outside of the nucleus. So first, in our first orbital, as it says in our electron configuration, there's 2 electrons. That first energy level is full once it has 2 electrons in it. That's all it can hold. So additional electrons go to the next level out. This next level will hold 8 electrons, and it will be full. So we draw those dots on those orbitals. We spread them out roughly equally. And then we need one more orbit here with how many electrons? 3. And that's an orbital model of an element. So we got fluorine here. How many protons in fluorine? 9. How many neutrons? 10. Okay, its electron configuration is a little different. Its first shell is filled up with 2 electrons. The second shell is not completely full. It has 7. So another way we can do this sometimes is we write just the number. Instead of drawing all the dots, we can just sort of write the number right next to the orbital. Then finally, magnesium. How many protons? Neutrons? And then the electron configuration is 2, 8, 2. So that's one way to do it. We actually don't do this very often. Because in chemistry, most of these electron orbital levels are not that important when we're trying to study the behavior of an element, or how it bonds with other elements, and how it reacts, how it forms compounds. When we're looking at those things, the most important factor is this last number, the outermost shell of electrons. We call it the valence, those valence electrons, the outermost shell. So are these drawn to scale? Obviously not. If the nucleus is this large, we'd have to draw these electrons way up in the sky. Okay? That's not the scale of the atom, but that's just one way we can picture it. So the next type of drawing that we do is called the Electron Dot Diagram. It's simpler, and it allows us to sort of visualize and is used in predicting how different elements will bond to each other. So for the Electron Dot Diagram, we start by just writing the symbol of the element. And then we only look at the outermost electrons, the valence electrons. In this case, how many valence electrons does aluminum have? 3. Okay? So we put a dot on the top, and we work clockwise. And we put our 3 electrons. Fluorine. Fluorine is how many valence electrons? 7. So 4 around, and then we start filling in a second one on each side. So with fluorine, its second energy level has 7 electrons. Now, what would make this full? Hayden?
7.
7's not full.
Oh, because if you go 1 more, then it will be.
8 would be full, right?
Yes.
So 1 more electron here fills up this outer shell. So, you could start to think about, all right, well then, what kind of things would fluorine form a compound with? Okay? What it's looking to do is fill up this outer shell. So it would be looking for an element that had 1 extra electron that it can either give to fluorine or share with fluorine so that it would have a full outer shell. And we'll talk more about that next week. Let's do magnesium. Magnesium has 2 electrons in its outer shell. So we have our 2 dots. Aiden?
What's the
We'll talk about that as well. That's called its oxidation. So the order we go in, clockwise. You get this, right? Start at the top, and the second electron goes to the right. If you understand, you don't really need to write all the dots in. We just go clockwise. So let me ask you this. Which X would this one be likely to form a compound with? This first one. It has 1 extra, right? And it could share that with this. Or, let's look at this one. This might bond with 2 of those. So each of these fills in one of those gaps and we form a compound. That's what water is. Hydrogen has, this is hydrogen. This is oxygen. So 2 hydrogens bond with 1 oxygen and they all have full shells. All right. Go ahead, grab your periodic table. And let's just quickly do these electron dot diagrams. It probably takes longer to find the element than it does
Yeah.
actually make the diagram. Yeah, because those are synthetic man-made elements that only exist for like a fraction of a so you guys understand the basics here. What is Na?
Sodium.
Sodium. Let's look at sodium's electron dot diagram. How many valence electrons does it have? Just one. How about chlorine? How many does it have, Carter? 7. Now, so why is it so? What do you think about sodium and chlorine when they are near to each other? They can make a compound. The one, because the first energy level, how many, so what if sodium got rid of this? What would be, if it got rid of that one electron there, what's sodium's previous energy level then? 8. What is that? Full. And then it's stable and happy if it was able to sort of get rid of this or share it. Then it wouldn't have that one extra. Its previous energy orbital would be full and it'd be happy. How about chlorine? If sodium gives that or shares it with chlorine, chlorine's going to be full. It's going to be happy. So do sodium and chlorine form a compound? Yeah. What do we call it?
Sodium chloride.
Sodium chloride or
Big
salt. Okay, and that's why those form a compound, is because they both are stable once they do that. So what happens is sodium gives away this electron, gives it to chlorine, and then they form 2 ions which are attracted to each other. So yes, this helps us understand how things bond. Aluminum has 3 outer electrons. Now let's look at neon. How many in neon?
8.
Okay. So neon walks into a bar. Bartender says, "Hey, we don't serve your kind of beer." Neon doesn't even react.
Oh, I get it. Yeah, the noble gas.
Neon is a noble gas. What is its outer orbital like? It's full. Neon does not interact with other elements. The noble gases, the things on the far right of your periodic table, neon, argon, helium, krypton, xenon, those are the noble gases. They don't generally form any compound with any other substance because they don't need to. They have full outer shell electrons. They're happy just the way they are. They don't need somebody else to make them happy. They're forever alone. All right, so you see the other. And again.
I can
What?
I can relate to that personally.
It's okay. It's okay. Call you a noble gas, Dean.
Uh,
All right. Any other questions? Yes, Dean.
What about helium? Because it says it's only 2 there, but
Yeah.
isn't that also a noble gas?
Yep. What do we say about that very first energy level? Can it hold 8? No, look at all the previous elements that have a bunch. How many are in the first shell for all of them? 2. That first shell only can hold 2 electrons. It's when it has 2, it's full, it's happy.
Okay.
Carter?
So what happens when it fills with electrons? Does it just not, does it just stay?
Then it's stable, and it's connected usually with another element because they're either sharing an electron, so they're bonded together, okay, or one element gave away its electron. And if you give away electron, what happens to the charge? It's no longer neutral. If you give away an electron, what do you become? Nope. I gave away a negative. So I'm positive. That other element gained an electron, so what is it? If it gained an electron, what happens to its charge? What? If it gained a negatively charged electron, it's negative. So I'm positive, it's negative. Positive and negatives do what? Attract. And so then they form an ionic bond.
Does this happen all the time?
Yeah, this is how compounds form. This is how we end up with any compound. All right. Let me give you your homework.